So we're going to look here at linear and angular speed, okay? So before I explain what it is, so suppose that an object travels around a circle of radius r. Okay, so let's say we have a circle here, okay, and that's of radius r, and you have an object that is traveling along the circle. Okay, so think about it. There are two types of velocities in right. One is we have what we call linear speed. That is, how fast is it moving? How fast is the distance changing? That's my linear speed. And then the other speed that I have is what we call the angular speed. Is as this object moves, let's say this angle theta, right? If this object moves from here to here, then I have this angle theta changing. So I'm interested in not only how fast is my distance changing, how much distance is this covering along the arc, but I'm also interested in how is this angle changing? How fast is my angle changing? And so I have two kinds of speeds that I'm interested in here. I have the linear speed as well as the angular speed. Okay, so the linear speed is given by v equals s over t. Okay, and we know what s is. S is nothing but your r theta over t, right? S is your arc length. So again, it's the distance. The distance covered across this or along this circle is nothing but my arc length, and that's given by r theta over t. Again, theta is going to be in radians. Okay, and then the second one we have is our angular speed, and we represent that by omega, and omega is given by theta over t. Okay, and theta again in radians, theta is my angle, so that is the change in angle over time. And so I have two speeds. We have the linear speed, which is v equals s over t, or we have omega, which is theta over t. Now, if you compare these two equations, we get v equals r times omega. And how do we get this? Well, let's think about it. We have v, right, from here we have v equals r times theta over t. And what is theta over t? Well, theta over t is omega, so this is r times omega. And so I have three formulas essentially here. First one is for linear speed, where I have v equals s over t. Second is my omega, which is theta over t, or the change in angle over time. And the third one we have is comparing the linear velocity with my angular velocity, and I get linear velocity equals radius times your angular velocity. All right, so let's look at this word problem. So it says a model plane is attached to a swivel so that it flies in a circular path at the end of a 12-foot wire, which means for us, right, so for us, that 12-foot wire represents the radius, okay, and at 15 revolutions per minute. Now note here the unit. We have revolutions per minute. That indicates to us that per minute indicates to us that it's some sort of a speed, right? Now the thing is it angular speed or is it linear speed? So if you look at revolutions, when we look at revolutions, what's changing really, we're looking at the change in the angle. So one revolution represents a change in the angle of 2 pi, right? So one revolution for us is 2 pi. Okay, or we could, I mean, it's 360 degrees, but in these problems, we want, like I said before, we want to work with radians. So this is 2 pi radians. Now, if that's one revolution, what is 15 revolutions going to be? Well, 15 revolutions is going to be 15 times 2 pi, or 30 pi radians, right? So what's my angular speed here? My angular speed omega is going to be theta over t, where that's going to be 30 pi over 1, which is 30 pi radians per second, or per minute, I'm sorry. Okay, so that's my angular speed. That's the change in angle per minute, right? We have 30. The angle change is like it said here. The angle change is 15 revolutions per minute or 30 pi radian per minute. Now, we want to find the linear velocity. How do we find the linear velocity? Well, we know the relation between v and omega. We know that v equals r times omega. Okay, we know what r is. R is 12 times omega was 30 pi. And so this is going to be 12 times 30 pi, which is 360 pi. And here's going to be feet per minute. So the unit for linear is going to be feet per minute, because that's, remember again what I said, that is your distance that you're covering, and that's in feet. So how many feet per minute, whereas your angular velocity is going to be how many degrees or how many radians per minute.